Alright, so welcome to another video. Today we are going to look at how we can find the limit of this particular function right here. Today we are going to do full computations, nothing more. So this function right here, we have alternative ways that we can use to handle this particular function. But I want us to use the L'Hopital's rule to handle this particular function. You know, we can only apply the L'Hopital's rule when we are having a rational function. Of course, when we are able to have 0 over 0, which is an indeterminate, or infinity over infinity, which we don't know the solution, then we can go ahead and apply the L'Hopital's rule. So here, let's try to make this become a rational function, that is p over q, right? So when you find the LCM for this, you're going to have x out, e power x minus 1. This goes here, so we have, right, minus x, right? So of course, we are going to have lim as s approaches 0 of this particular function, right? So now we have a rational function. So let's do direct substitution and see if we can get 0 over 0. So clearly, when you put 0 here, you're going to have e power 0, which is 1. And when you put 0 here, you have 0. So you have 0 at the numerator, right? Let's check the denominator. 0 here means everything here is going to be 0. So we have 0, which gives us the opportunity, or gives us the liberty, to use the L'Hopital's rule. So 0 over 0, which is indeterminate. So we can go ahead and use the L'Hopital's rule, right? L'Hopital's rule says that when you want to use him, make sure you take the differential of the function with respect to each variable, right? So we are going to differentiate the numerator with respect to x, then we differentiate the denominator with respect to x. So here we go. Lim as s approaches 0, differential with respect to x of the numerator, right, all over differential of the denominator with respect to x, of course, right? So here, the numerator, let's tackle the numerator. So you know that differential of the numerator, which is e power x minus 1 minus x, will give us e power x. The differential of that is still e power x. Differential of -1 is 0. So we have minus 0 here. Differential of minus x is minus 1. Right? So finally, we have e power x minus 1 for the numerator. So let's tackle the denominator. So we have the differential of the denominator, which is x into e power x minus 1. This can be written as e power x e power x minus x, right? So here we can apply what we call the product rule at this junction, because we have two functions multiplying. So when we apply that, when we differentiate x, maintain e power x, we are going to have 1 times e power x plus, we maintain the x, then we differentiate e power x, which is going to give us e power x minus the differential of x, which is what? 1, right? So we have the denominator to be e power x plus x e power x minus 1, right? So we have the differential of the denominator as e power x plus x e power x minus 1. So now let's look at how we can evaluate them. So we have limit as s approaches 0. The numerator is e power x minus 1 all over e power x plus x e power x minus 1. Can we still apply direct substitution and have our solution? Let's try. When we put 0 here, we have 1. 1 minus 1 is 0. So we still have 0 at the numerator. When you put 0 here, we have 1, right? Plus, when you put 0 here, everything here becomes 0. All right, so we have 1 minus 1, which is 0. And then we are still getting indeterminate, right? So we can still go ahead and differentiate again. All right, so differentiate again. That is, we are applying the L'Hopital's rule the second time. So let's go. So differentiate the numerator with respect to x over differential of the denominator with respect to x. Right? Now let's take the numerator. The differential of the numerator with respect to x, of course, when you differentiate e power x, you are going to have e power x. Then the differential of -1 becomes 0. So the numerator, we have e power x. Let's take the denominator, which is e power x plus x, e power x minus 1. So when we do that, differential of e power x, the denominator, differential of e power x, we are going to have e power x. And then plus, let's differentiate this using the product rule. So we differentiate x, we have 1, then we maintain e power x. Then we maintain x, differentiate e power x, and that will remain the same, e power x. Differentiate -1 and we have 0. So we don't have anything at that junction. So we have the denominator to be e power x plus e power x plus x e power x. Right? So we have this. So now let's take the limit for numerator and the denominator. So limit as s approaches 0, e power x over e power x plus e power x plus x e power x. Right? So here we can boldly say that when we substitute x equals 0 over here, we are having the numerator to be what? 1. E power 0 is 1 all over the when you substitute 0 in place of e power x, we are going to have e power 0, which is 1. Of course, we have 1 here plus, of course, we are going to have 1, 2 here. Then when you apply 0 on this, we are going to have plus 0. So we have 1 over 1 plus 1, which is 2. Right, so we can say that the limit of this function is equal to 1 and 2. Therefore, the limit as s approaches 0 of 1 on x minus 1 on e power x minus 1 is equal to 1 on 2. Right. That is it. Thank you very much, ladies and gentlemen. Don't forget to press on the notification bell, subscribe, share with your friends, and I'll give you more content.